All right, welcome back. So last week we had a discussion, or at least a presentation, about plant diseases and some of the more common ones you may get to see out there. So today we're going to talk about parasitic plants, which they are going to be treated as a disease. So remember, with diseases, they were being caused by viruses, by bacteria, by fungi. The nematodes are going to be part of that. And so there is going to be a group of plants that have figured out that instead of carrying out the extensive work of photosynthesis and making their food, that they are going to rely on other plants to do that, and they're going to steal the resources, making them a parasite. And so here on the screen, we have one of the more common plants that you might see out and about if you ever go to some of the more native areas. This is a photograph from Griffith Park. And the mountains are going to be kind of yellowish. And this is going to be a California native plant known as dodder, or witch's spaghetti, or witch's hair. Now, in the mountains, it is not a problem. It should not be considered a problem because it is part of the native plants. However, it may make it into the city. So here is a plain suburban area. And the ficus, the figs here, you can see the strands coming out of the plant. And so somehow this individual happened to have a seed that was landed on it. And that is going to be the case. Since they are higher plants, they will have a flower and they will have seeds. And so through using birds or other means, they're going to move around from one plant to the other. And when they happen to detect that plant, then they're going to germinate. The moment they germinate, what is should be the root of this plant is then going to burrow into the stem of the host, and it's going to make a connection with the vascular system, and that's how it's going to begin to take away the resources. So again, the roots, instead of going into the soil and doing all that work, is now going to act as a siphon, penetrating the stem of the host plant. And so here's a closer picture of that ficus fig tree, and you see all the strands. As the strands also move around, if there's in close proximity to another plant, they will kind of wrap themselves onto that plant and they can continue on to spread. If we also look at this close up, you can see where that union is taking place. So this is where you can see the daughter here, and you can see the stem of the host plant. So here is where the plant is attached to the host, and here is where the parasite is taking the nutrients, the resources from its host. We also see a flower because it is a higher plant, so a seed plant. And here is a few more shots of some of those parasitic plants and where they are being, they have that connection attachment to that specific host. And here's the close-up of the flower. In this case, this daughter is related to morning glories, and that's why it happens to be more of a binding individual. But anywhere where it can make a connection to the host plant, it will, and that's how it's going to take its resources. And so eventually this may weaken the plant. However, daughter is an annual plant, and so it's going to die at the end of the season. It may come back the next year from seeds. And there's a close-up of the flowers. There's going to be a few other native plants. These are going to be Indian paintbrush, and this happened to be semi-parasitic. Semi in that they'll still have some green, they'll still have some photosynthetic areas, so they can produce some food. However, below the ground, they will have a connection to the roots. And so not only can the parasite connect to its host on some of the stems, depending on the individual, but some of them may choose to connect through the roots. And that's how they're going to steal the resources. And so Indian paintbrush are going to do that. And we also have here what is known as snow mushroom or snow fungi. It is a parasitic plant. And so in this case, this is a native parasite to Northern California. So its host is going to be some of the redwoods and some of the giant sequoias. And it's going to be snow mushroom because it kind of looks like a mushroom. And you can see where it's just coming out from the snow. In this case, the entire plant is below the ground. You don't see the plant. It has no need to come out because it has no photosynthesis chlorophyll. And so what you only see is going to be the fruiting body. So the flowers that you see right here that will get pollinated and seeds will get dispersed, hopefully make a connection with a plant somewhere else. So here is kind of what happens. So we have some of the seeds that are just going to drop to the ground. And when they feel a root that is in close proximity, they are then going to germinate, and they're going to then make a connection to the vascular system of that host plant. And then as it seals the resources, then they're going to send out the flowers that will then have more seeds for the future. So that's in a drawing what happens and how the parasitism takes place with this. Now, this is going to be a smaller problem back east because they are problems with growing corn and other agricultural products. But around here, you don't really see or hear too many things about it. And then somewhere in the tropics, you have what is known as blood mushroom. And it kind of looks like a mushroom, but it is the flowers of that another parasitic plant. And these photographs happen to come from Brazil, where I happen to have find them, and I took a photograph. So blood mushrooms. So once again, the plant is below the ground. You never see it. Even the flowers, they're not really green because they don't have a need for photosynthesis. And here's where the actual flowers happen to be open, and those will be pollinated. And then the more famous one would be mistletoe. So mistletoe is a parasite. It's native to California, and depending on where you go, it's going to be different. So, and its host is going to be different. So many of them are going to be very specific to a host, and those are going to be some of the high altitude that may parasitize some of the pines, some of the junipers, and a few others from our chaparral area, such as the photograph you see here, might be a host to some of the sycamores, some of the oaks, some of the walnuts, and a few other non-native plants that we'll go to. So here we have several branches that have the mistletoe growing off of the stem. And here's another one where you see the mistletoe draping. Mistletoe is meant for Christmas. It's sold by the Boy Scouts, and it's nothing more than a parasite for any other means or purpose. And here you can see the attachment where the plant gets attached by or parasitized by the mistletoe. You may see a gall or some kind of grotesque growth. It's just where the two vascular systems meet, and it's how the plant is responding, having a parasite attached to it. There is no real way to control this. Many times, if the infection is really bad, the weight of the mistletoe may break branches, or because it is taking some of the resources from the sycamore or the host plant, if there are other environmental factors that continue to weaken the plant, then eventually the plant may perish because of all the stress. But otherwise, all these parasites require some kind of living host to keep on feeding. Here's some leaves mistletoe. Last time I also mentioned, or before, we also mentioned some of the galls. So here are some of the galls that are caused by insects. So these are called oak apples. And it is not an apple, it is a gall, a tumor that is induced by an insect, a very tiny wasp that will lay its eggs. And the tissue that is the product of the tumor or the gall is going to be fed upon by the young wasp. And here you can see the hole where the individual came out. Every so often you might see something like this, where there is an entire leaf that damage goes across. And I keep hearing, oh, this is some disease, and it's not. This is just a damage from an insect. And what happens when the leaf is very small, there may have been an insect that would chew through the middle or somewhere. And so as the leaf matures and unfurls, then the damage becomes noticeable as a straight line. And so this is just an insect damage, but I see it very often, and people often send me photographs asking me what's causing this or what's the disease that I am dealing with here. It's too uniform, it's too nice. You can see a smaller one over here. You can see a combination of different damage right here. So not a disease, but damage done by an insect when the leaf was very, very young. And then I mentioned before, may have mentioned, plants that are variegated. And the word variegation you should be familiar with. And variegations are just natural mutations, where in this case we have an agave that is unable to produce chlorophyll the normal way. And so that's going to allow some of the hidden colors, in this case, some of the whites, to be greatly exposed. And so this is now something that is desirable by the horticulture industry. And there's going to be individuals that happen to like this or are going to be sold at a very, very high price. Nothing more than a mutation that is preventing the plant from carrying out the production of chlorophyll properly, and thus photosynthesis. It's going to be weaker. It's going to be sick because it is a mutated individual. It is sick. So just be aware of that. Here's a Foxtel asparagus or asparagus fern, and you're going to see the lighter color leaves. That is the variegation. So the normal ones are going to be this deep green. However, you can see a change in color. That is a desirable trait. You can see here with some of these palms where there is an off color on some of the fronds or the leaves. That is the variation, and that is the desirable character. And you can see here on this clivias where you have also something different. And here's very expensive. So if you Google variegated clivias, some of them can sell in the thousands of dollars to collectors in Japan and other parts of the world. So they're looking for that mutation. They're looking for that weird individual. Here's some bromeliads that again cannot produce chlorophyll, and that's why they have that pattern. So as you're looking around, just make sure that you don't, now that you start blaming problems with pathogens and diseases, because often it's not going to be the case. And what I want to point out here is that the coloration is uniform. You have the same pattern in every single leaf. And so when you have something like that, you know it is not a disease, because diseases are going to be more spotty here and there, and that's how you can determine. So if every single leaf in the plant has the same pattern, then you know it is not caused by a disease. Here's Monstera. So once again, people are paying top dollars for them right now. They cannot get them, propagate them quickly enough for people, especially the variegated. They're going for tiny cuttings at about $60 to $80. And we're talking about pieces that are about 2 inches, so barely rooted. And people are buying them. And the more variegated or the weirder, the better. So here's some variegated with white. Here's some variegated with yellow. So natural changes. So Here's that's probably about $500 plus to some of those millennials who are looking for this. And so with that, I know it's kind of short, but it's just some of the other problems that you may encounter that are not diseases, but you may see them out. So take care. Have a good weekend. Bye.